Hello students, today we will do the next part of PN junction diode, that is the PN junction diode as the Zeener diode. Zeener diode is the very important one. Zeener diode is nothing but the simple PN junction diode. There is no speciality in the outside cover, but then inside there is a speciality. And for this reason Zeener diode is named, and Zeener diode actually this is nothing but the PN junction which works in the reverse bias condition. But the speciality is that it is given there, it is heavily doped. This is the mechanism which you make inside it, that is, it is a heavily doped PN junction diode, but it works in the reverse bias condition. What is the use of it? Actually we use it as a voltage stabilizer, because suppose in a circuit like TV circuit, several places are there, small places we have to supply some steady voltage. That means we need a voltage stabilizer. So each and every place we cannot make on big stabilizer there. We use the Zeener diode because it stabilizes the voltage. Current may increase long, but the voltage remain constant. So this property is there in Zeener diode. Now come to the theory, how it works. It is a little bit critical theory. Just see, this is one normal PN junction. This is the normal PN junction diode, and this is our Zeener diode. Suppose this is our Zeener diode. So these will be connected in reverse bias. Now the connection is not there. Remember, there is no connection. So before connection, see what happened. Here the concentration is normal. Here the concentration is more because it is heavily doped. So it is heavily doped means concentration of electrons in the conduction band is more, and the concentration of holes in the valence band is more. So this is the concentration more, this is concentration less. After that we know the normal PN junction, when we connect in this way, before connecting the battery, depletion layer will be created. Okay, just see, this electron will come, this electron will come, this electron will come, they will occupy the space of the holes, and automatically they create this type of depletion layer, which happens here also, same thing. Here also electron jumps and occupies the holes. In this way one depletion layer will be created. But see the difference, what happened here, in this particular case we get the depletion layer like this. Make this let me use the same color. Suppose this and this is our depletion layer, and here it is the depletion layer. And when these holes and electrons they recombine, we know that we don't get any free charge in this region. They will recombine and we get a free space. That means there is no free electron, no holes, only the silicon atoms are there. Here also we get the same thing. But now see, before connecting the battery, in normal PN junction diode and in Zeener diode, what difference is there? Difference is that depletion layer size, it is bigger, it is smaller. But see, the barrier potential is same. Here the barrier potential, here it is positive and negative. Suppose V potential, here also it is negative and positive. Here is the positive, here is the negative potential arises, and that is also V. Both the cases, the barrier potential remains same, 2 volt like this, but the size of the depletion layer is bigger, it is smaller. This is the speciality of the Zeener diode, and it happens due to this type of heavily doping of PN junction diode. Now another point you have to make it from here only. We know that the electric field and voltage, they are related in this way. We know that EV equal to dV by dx. So from there we can write that our E into distance d equal to the voltage. So E into distance d equal to voltage. In both the cases voltage are constant. So in this case E dot distance equal to the voltage. When here the distance is bigger, automatically electric field will be low. And in this case E dot d is also again equal to V. But in this case d is very small. D is small means E should be the bigger one. So from this example we can see, in this case as the depletion layer is the bigger one, we get one small electric field. Electric field will be small. So with pens we can write in this is the electric field. But in this case we get a bigger electric field. So this is the main vital point. Due to the concentration more, depletion layer size is small, and for that this electric field is bigger. This line indicates the electric field. Electric field is the bigger one. Okay. Now let's come to the point. Now we'll connect this is the beginning before connecting the battery. This is the position that in case of normal diode we get inside it in the electric field is small, but in this Zeener diode the depletion layer is small. For the same potential we get a high electric field. Okay. Now connecting the negative reverse bias, this is P, this is N. So automatically P with negative, N with positive. This is the reverse bias here also. P and N type. So P is with negative, N is with positive. We connect in this way, and here is one variable resistance so that we can change the voltage. Okay. So this part is over. Electric field concept is over. We know I have seen that here the electric field is more, here the electric field is small. Now you connect the battery. What will happen? We know in normal PN junction diode we have seen when you connect the battery in reverse bias, we know that the negative pole will pull all the holes this side and this positive pole will pull all the electrons in one side. So the holes and electrons will go into different sides. So automatically depletion layer is now more. There is no possibility of passing the current through this one. This was the already you have seen in reverse bias PN junction diode. So if I draw the graph like this, current is here and voltage, negative voltage is here. So as much as voltage you can increase, more and more electron and holes will go to the right hand side and left hand side. In this way they will spread and the depletion layer will increase in size and there is no possibility of current. So we get this type, very small current we get, but it is negligible one, we don't get any current like this. This is the graph in PN junction diode. Yes, one more point is there, that is the breakdown case. Yes, there is there. Suppose when the voltage is high enough, negative voltage, then what will happen? The minority carrier of p type, who is there? Electron is the minority carrier. Already we discussed this point. These minority carrier electron will try to shift here. They will try to move when the voltage is high. Already have done. Voltage is high, too high range. So it will come there. After that, what I said there in last video, that here the silicon atoms are there. These electrons will hit the silicon atom outer shell. Automatically from the valence shell electrons will come out. So this is one free electron and from the outer shell electrons will come out. In this way, from so many silicon atoms we can get huge number of free electrons. This was the free electron, that is the minority carrier. What it did? It hits the silicon atom here in the depletion region and automatically brings out the electron from the silicon atom. So we can get a huge concentration of free electron here, and when these electrons will flow, we get a huge current. This is the reason why we get the breakdown case. Breakdown case, always remember, this is the vital point regarding the difference. Here's the electron from the minority carrier, electron is here, p type. So they will hit the barrier case and barrier silicon atom will release the free electrons. When in this way, when so many silicon atom will release huge number of electrons, they will pass and we get a current. We call this is the negative current or the breakdown current, and this voltage also have the name we call the breakdown voltage. So this is called the breakdown voltage, and the case, that is the minority carriers is hitting the silicon and from there they are bring out the electrons, so the electron concentration is high. This effect has the name we call the avalanche breakdown, AVLANGE, avalanche breakdown also. Sometimes we call this is the avalanche breakdown. So in higher studies, if you get the avalanche breakdown, remember this is the avalanche breakdown. That means the minority carrier when hits the silicon atom and brings out the electron, this electron will start the negative voltage, huge current we can get. Suddenly we can get a huge amount of current. This effect is called the avalanche breakdown. Okay. What is the problem? Problem is that as the electrons are hitting the silicon atom, it produces the huge amount of heat. That is the problem. So due to this continuous collision, some huge amount of heat will be developed. So due to this generation of the heat, ultimately this PN junction diode will destroy. This is the negative side of the reverse breakdown voltage of normal PN junction diode. Because due to this electron, they will hit the silicon atom and they will produce the continuous heat. And this heat is enough to destroy the PN जंक्शन डायोड. So इसलिए क्या होता है, जो नॉर्मल डायोड में जो PN जंक्शन डायोड होता है, इसके एवरेज ब्रेकडाउन में जाने का बाद वो डायोड हम यूज नहीं कर सकते क्योंकि वो डैमेज हो गया पूरा पूरा. ड्यू टू दिस कलीशन ऑफ द इलेक्ट्रॉन दे विल प्रोड्यूस द हीट एंड इतना हीट डेवलप करता है जो पूरा PN जंक्शन ही खराब हो जाते हैं. So this is the problem with negative bias of the normal PN junction diode. Now the question comes, what is the specialties in Zeener diode? Come to the Zeener diode now. In Zeener diode also, when this way, let me draw the graph. We are increasing the negative voltage, current is there, negative voltage is there. You are increasing the voltage gradually. If I increase the voltage, according to this, no current will flow because the depletion layer will increase in size. Here it will increase in size more, here it will be a little bit less. But anyway, the depletion layer size will increase. So automatically we don't get current, like same type graph, we don't get current here. But you may ask now that is this thing happen? That means the minority carrier of p-type will go there? No, this thing will not happen. Why? Because see, Already we have done. This electric field is very strong electric field. So as the strong electric field is acting in between these two, so this strong electric field is enough to bring out the electron from silicon atom. So here is the difference. Here, until and unless the minority carrier will hit the silicon atom, we don't get the free electrons. But in case of Zeener diode, there is no question of minority carrier to move. No need, because electric field is strong. Here the electric field was very small, weak, so it cannot break out the silicon atom. इसलिए क्या होता है, माइनॉरिटी कैरियर को चाहिए. माइनॉरिटी कैरियर आके उसको ब्रेक करने के बाद हम इलेक्ट्रॉन मिला है. लेकिन यहाँ क्या होगा, माइनॉरिटी कैरियर आने का पहले ही इलेक्ट्रिक फील्ड इतना ज्यादा स्ट्रॉन्ग हो गया, इतना ज्यादा स्ट्रॉन्ग हो गया, इसमें जो सिलिकॉन एटम है, सिलिकॉन एटम को ब्रेक कर देते हैं. तो इसमें जो फ्री इलेक्ट्रॉन जो मिलता है सिलिकॉन एटम ब्रेक करने के बाद, ये फ्री इलेक्ट्रॉन किस लिए आता है, ये मत सोचिए जो माइनॉरिटी कैरियर आता है. माइनॉरिटी कैरियर का कोई फंक्शन ही नहीं होता है, क्योंकि स्ट्रॉन्ग इलेक्ट्रिक फील्ड के लिए सिलिकॉन एटम का जो ब्रेकिंग है वो ऐसे ही हो जाते हैं. So we get huge amount of free electron, but not due to the collision of the minority carrier, but due to the effect of the strong electric field. So what happens? We get huge amount of electron again we get the current like this. So see here, we have to move a long to get the breakdown voltage. Here very short period we can get this one, because the electric field is very strong. It is ready to break up the silicon atom to bring out the free electrons, and it starts current like this, in this way. So now the problem, can I use it next time? Will it damage? No, this will not damage, because here the electrons were hitting the silicon atom. That's why we can get the free electron. It develops the huge amount of heat. But in case of Zeener diode, is there any collision? No, there is no collision of electron. So who is responsible? Electric field is responsible. So when electric field will bring out the electron from silicon atom, there is no question of producing the heat. So there is no question of generation of heat. So it means that the Zeener diode will not destroy. That is the difference. It will not destroy, but it will destroy. We can use it next time also, because there is no generation of heat. This is the basic difference. And when it happens, now see, what is the purpose of this also? In this way we can use the Zeener diode, because as the generation of heat is not there, so we can use in the reverse bias condition, we can get the current like this. So this is called, this is also breakdown voltage. We call this is the Zeener breakdown. Actually this is called the Zeener breakdown, to just identify. See, this is also breakdown, this is also breakdown. This is for normal PN junction, and it will destroy the PN junction. But here we get very short distance, or very short voltage, you can get the Zeener breakdown, and we can use the diode again, because there is no generation of it, there is no question of destroying the PN junction. That is the Zeener diode. Now the point is that in Zeener diode, what is the purpose? How can we use it a voltage stabilizer? Just see one point. Let me drop this name. So suppose in this particular voltage, suppose it is VZ, V Zeener voltage. See, when the current is this much amount of current, now the voltage is like this. When you reach to this current, that means huge current you got now. See, the voltage is not too much changing, it remains constant. So whatever be the current increases more and more and more, voltage remain constant. So can you use it as a voltage stabilizer? Yes. So this is the purpose. Zeener diode is used as a voltage stabilizer. So as much as current we can get, but the voltage remain constant. So this is the use of the voltage stabilizer. So in highlights, in short, what we can say, normal PN junction diode and Zeener diode, they are nothing but simple PN junction diode. Difference is that concentration level, that is the doping in case of Zeener diode is more. Due to the doping, what we have seen, that the depletion layer is small, here depletion layer is big one, but voltage remains same. Voltage means the barrier voltage producing in both the cases are same, but इसका small छोटा होता है, ज़्यादा होता है. तो इसमें क्या होता है, small होने के बाद E equal to E dot D equal to V इस रिलेशन से हम देखते हैं इलेक्ट्रिक फील्ड यहाँ ज़्यादा होता है. तो ज़्यादा इलेक्ट्रिक फील्ड के लिए क्या सुविधा है, देखिए अभी जो इनके सब नॉर्मल पीएन जंक्शन में क्या होता है, जब माइनॉरिटी कैरियर आके सिलिकॉन एटम से इलेक्ट्रॉन निकलने के बाद वी कैन गेट द करंट लाइक दिस. But in this case, no need of movement of any minority carrier. Electric field itself is enough. Electric field itself is enough to bring out the electron from the silicon atom. So when this electron comes out, we can get a huge amount of current. So as there is no collision of the minority carrier, no question of producing the heat, and there is no question of destroying of the diode. So this is the use. We can use the Zeener diode again and again, and we should connect in the reverse bias, so that when voltage remain constant, we can get the huge amount of current. So This will give you the idea about the Zeener diode, how it is used as a voltage stabilizer. Hope the idea is clear. Okay, just look repeated view. We can get some idea about your Zeener diode in voltage as a voltage stabilizer. In higher study also you will get this one. Okay, thank you.